Hi there! Welcome again to SPIKY, the MATLAB-based graphical user interface for monitoring spike train synchrony. In this movie, we show you how to look at the significance of a certain spiking event on the overall synchronization of a collection of spike trains. To illustrate this effect, we will now use one of our standard examples, this time not the clustering dataset, but rather the spiking events dataset, which we select from the list by a double click. The spike distance is already pre-selected, so we just confirm. This shows us the dissimilarity profile and its average. For our test dataset, we find a value of 0.196. So now we want to see how much of this rather low value is due to the drop in the dissimilarity profile caused by this spiking event at 400 milliseconds. Since it is a perfect event, the dissimilarity profile goes down all the way to 0. One way to do this is to eliminate this event and to see how the spike distance value changes. To do so, we first reset the plot, but we make sure that we keep the data, which means that we don't press the reset button, but rather reset with same data button next to it. Then we can open the spike train generator, which in this case acts as a spike train editor. Now comes the tricky part. We want to eliminate all spikes from this spiking event, but not other spikes. So we keep the Shift button pressed and very carefully select all spikes in the event. Once this is done, we can use the right mouse button in order to delete them. We can confirm this modified dataset by pressing Done, and back in SPIKY we calculate the spike distance again. And voila! As you can see, the early drop in the dissimilarity profile has disappeared, and this results in an increased value of the spike distance of 0.2, a bit higher than the previous value of 0.196. This was just meant to give you an idea about some of the things you can do with SPIKY. We will deal more thoroughly with the whole topic of significance in a future paper. So that's it for now. Cheers!